Percent composition and chemical formulas, section 10.3. When we're talking about the percent composition of a substance, what we mean is the relative amounts of the elements by mass in that compound. So for instance, if we're talking about water, water is 89% oxygen and 11% hydrogen by mass. Or if we were talking about potassium permanganate, it's 40% potassium, 26.8% chromium, 32.9% oxygen. So the question is, how do you figure this out? Well, the first thing you need to do is find the molar mass of these compounds. So when we're talking about this particular one, we would go, well, it's 2 times 39.1 plus 52 plus 4 times 16. And then add that all up. So let me get my calculator here. So I got 39.1 times 2 plus 52 plus 64. So that equals 194.2. And then what you do is you figure out, well, if I want to figure out percent of potassium, I take the potassium. So here's my potassium, and I would put it over top of that. So 2 times 39.1, or that would be 78.2 divided by 194.2. And of course, you always take them times 100 when you want percents. So 78.2 divided by 194.2 times 100. And I get 40.267, so that would round off to be 40.3%. If you were doing chromium, if you're doing this one, you would take the 52 divided by the total, 194.2 times 100, and you'd get that 26.8. And if you're doing oxygen, you would take the 4 times 16. No, I can't write very well here. Try that again. 4 times 16, which is 64, and divide that by 194.2. And you would end up with 32.9% for oxygen. So there's kind of the written formula of what I just did. You're taking the mass of the element, you're dividing by the total mass of the compound, take it times 100%. Alright, let's take a look at this example. It says when a 13.6 gram sample of a compound containing only magnesium and oxygen is decomposed, 5.4% or 5.4 grams of oxygen is obtained. What's the percent composition? Well, this is, just remember, you know, your basic thing about percents, it's always the part over whole. So if we wanted the part, it's 5.4 grams over the whole thing. When it was in a compound, it was 13.6 grams. So just take that whole thing and do that. So take the 5.4. Kind of lost a connection there for a second. I'm not sure why. Anyway, so we're going to take the 5.4 divided by 13.6 times 100. And when you do that, you're going to come out to be 39.7%. That was for oxygen, so it's 39.7% oxygen. If you want to figure out the magnesium, you know, if there's only 2, the easiest way is just take 100 minus that, and you're going to get 60.3% because there's only 2 things. Or you could subtract the difference. That would be the 8.2, and then divide that by 13.6 and take that times percent. But I don't see a point in doing it that way. It just seems to be easier to do it the other way. All right, would you guys, would you try 32 and 33? Stop the video, try 32 and 33. All right, 32 says a compound is formed when 9.03 grams of magnesium combines with 3.48 grams of nitrogen. What's the percent composition? Well, part over whole. So in this one, the part is going to be, let's say we're doing magnesium, 9.03. The whole is the total of those two, 9.03 plus 3.43 times 100. And when we do that, what we're doing here, we're doing magnesium here. And when I do that, I end up with 72.2%. So if I'm pretty confident I did that one right, I know that the other one is just going to be the difference between that and 100. So this one was magnesium, and nitrogen would be 27.8%. On the next one, it says when a 14.2 gram sample of mercury 2 oxide is decomposed into its elements by heating, 13.4 grams of hydrogen, or of mercury rather, is obtained. What is the percent composition of the compound? Well, so 13.2 grams divided by the whole, 14.2 grams, times 100. And when I calculate that out, I'm going to end up with 93% for mercury. Therefore, the oxygen must be only the 7% left. Okay, what if all we have is the formula, chemical formula, and then we can just consider it to be a mole of the compound and figure it out from there. Take a look at the sample problem on page 307. I don't have that one very well. I have it, but it's not very good. So you can take a look at that. And it says propane C3H8 is one of the compounds obtained from petroleum. Calculate the percent composition of propane. So if I know that it's C3H8, what I can assume is, let's say I have an entire mole. Well, if I have 1 mole of that, I would have 3 times 24, or I'm sorry, 3 times 12. 3 times 12 plus 8 times 1. So 36 and 8, that's 44 grams. So the total is 44 grams. And if I wanted to figure out the percent carbon, I would put my carbon, which is this one, the 3 times 12, or 36 over 44 times 100. And that would give me 81.9%. I could do the same for hydrogen, 8 over 44, or I could subtract. And when I do that, I'm going to end up with roughly 18%, probably about 18.2, 18.1%. Okay. Why don't you try this one right here, 34. Do 34. Alright, so the first one is ethane, which is C2H6. Hopefully you can read that. So 2 times 12 plus 6 times 1, 24 and 6 equals 30 grams. If I want to figure out carbon, it's going to be 24 over 30. 24 over 30 times, should be times 100. 24 over 30 times 100 gives me 80%. And if that's 80%, then my hydrogen. Okay, so let's do B, and B is sodium hydrogen sulfate. So we add all that up. We get 23 plus 1 for hydrogen plus 32 for sulfur, 4 of oxygens. That adds up to be 120 grams. And then if we want to figure out each individual one, sodium would be 23 over 120. For hydrogen would be 1 over 120. For sulfur, it would be 32 over 120. And for oxygen, it would be 4 times 16, or 64 over 120. All of these are by 100 to get percents. And our percents for that would be 19.2 for sodium. For hydrogen, pretty small, it's going to be 0.83%. For sulfur, we would get 26.7%, and oxygen 53.3%. Okay, so there's our percentages for those. Okay, now what if they said I have 82 grams of propane, and we want to know what percent, or how many grams of carbon, how many grams of hydrogen do we have? Well, the first thing we need to do is figure out what the percent composition of propane is, and it's 81 and 18. And the reason we did that before, if you recall, so we're going to take the whole part over whole. So like for carbon, it would be 3 times 12 plus the whole thing was 44 times 100, and that gave us about 82%. So we figured out our percentages that way. If we want to now figure out what percent of this 82 grams is carbon, we would take 81.8% of 82 grams. And if you're taking percents, really we're taking 0.818 times 82.0. And when I do that, 0.818 times 820 equals 670. How about if this was 82.8? So let's make it 67. 67 be 67.07, or let's say 67.1 grams of propane. And so then the other, if that was 67.1, we take 82 minus 67.1, and I would get 14.9 grams of hydrogen. So that's how I could figure it out. Just by, if I had the mass and I knew the formula, I could figure out how many grams of hydrogen, how many grams of carbon I would have in each one.